Hi, let's look at some limits with piecewise functions. This first example, we've got f of x is x squared when x is less than 1, and 3 minus x if x is greater than or equal to 1. And we want to evaluate this limit. The limit of f of x as x goes to 1. And we're going to do the left-hand limit, the right-hand limit, and then the overall limit. All right, so for this limit, as x goes to 1 from the left, notice what this means. X goes to 1 from the left. That means that, if we think of this as our number line, x is approaching 1 over here, but it's approaching from the left. So it's like x is coming in over here. If you think about what that means, x is coming in from over here. If you think about what that means, x is less than 1. So that means that we're going to be using the x squared. So this is equal to the limit as x goes to 1 from the left of x squared. And we'll see this later on. We could draw a graph if we wanted, but we'll see later on that really all we have to do when we have a polynomial like this is just plug the number in. So I'm going to plug that 1 into x squared, and I get 1. That's my limit. All right, if we're approaching 1 from the right, that means on our number line we're approaching 1 from over here. So x is over here, and so x is greater than 1. So that means we want to use this piece here for when x is greater than 1. So this limit is equal to the limit as x goes to 1 from the right of 3 minus x. I can just plug my 1 in now and get 3 minus 1, and that's 2. All right, so now to do the overall limit, really what we have to do is do the two one-sided limits. We already did those, so since the two one-sided limits are not equal, this limit does not exist. All right, let's do one more example. Here we're splitting things up at 3. So we've got this function f of x is x plus 1 if x is less than or equal to 3, and f of x is 1 if x is greater than 3. So in this case, what I want to do is look at each of these limits. If x is going to 3 from the negative side, we've got 3 here. If we're approaching from the negative side, that means x is less than 3. And so we want to use the top part of the function. So my answer there is 4. If we approach 3 from above, it means we're coming in over here and x is some value greater than 3. That means we're looking at the bottom part of the function. The limit as x goes to 3 of 1. Well, that's just 1. So we've got two different values for the left and right side limits. So the overall limit does not exist. All right, that's it.